splice looks innocent, but in large arrays it can silently tank your performance. Here's what's really happening. When you call splice, JavaScript modifies the array in place. After removing an element, every element after it must shift down to close the gap. Each gets a new index. Remove the first item from a million-element array, and the engine must reindex nearly every element. That's not a trivial operation. This gives each splice call an O of n time complexity. It scales linearly with the array size. Call splice in a loop, and you've accidentally written an O of n squared algorithm. A classic performance trap that hits hard at scale. Where you splice makes a big difference. Removing from the end costs almost nothing. 0 elements need to shift. Remove from the middle and roughly half the array moves. Remove from index 0 and every single element must be reindexed. For cleaning up multiple items, use filter instead. It builds a new array in O of n time with no reindexing. If you need in-place removal, iterate backwards from the end so each splice only affects already visited elements. And for large removals, be aware of potential garbage collection pauses as JavaScript reclaims the freed memory. Splice is O of n due to element reindexing. Reach for filter or slice first, and splice from the end when you must. Ready to practice for your next interview? Interview Mentor lets you answer real questions just like this one. After each answer, you get a detailed grade and personalized tips to improve. Watch your scores climb as you keep practicing.